Hi, good afternoon. This is Mr. Cassidy. I'm going to give you a brief tutorial on how to do the stained glass window project. I won't do every step of the way. You'll have to figure out some parts of it for yourself. So let's begin. I would start by making 8 lines and writing the equations of those lines. So let me go ahead and draw my first line like this. Oh, I did not mean to have the triangle tool. Let me try again. Okay, first line is going to be here. And I am doing this sort of the hard way, which I'll explain more in a bit what that means. Alright, so there's my first line, and I would go over to my equation page. Again, we have a requirement of 8 lines, so I'm going to do the y equals mx plus b of this line. So let me go ahead and figure that out. Y equals mx plus b. B is for begin, that line begins, the y-intercept is 5. And the m, the slope, it looks like it's going down 1 over 2, so negative 1 over 2x. Alright, I'm going to go ahead and erase a bit, but I'll save that, because I want to remove that little triangle on my screen. So that line, the purple line, is y equals negative 1/2 x plus 5. Alright, so I would repeat that process 2 more times. Let me go ahead and do another line here. Let's say my next line would be from, I'm going to go from the origin here and go up like this. I've planned this out in advance so that I get a nice triangle here for my work. Okay. Now I'm going to stop there because my graph paper here is actually not a very good scale, and the slope will get off. But I'm going to leave it like this. I'm going to go ahead and get my equation of that line. B is 0. And the m is rising 2 over 1, so 2x, or 2 over 1x. Alright, for a third line, I'm going to choose green now, and I'll do, how about I do a line, I'm going to start about here, because I see a nice coordinate here that I could connect with a nice coordinate here, and I think that'll work nicely for my stained glass. So I'm going to go ahead and... So let's pretend that that extended all the way. My line tool here, I'll redraw it for you guys. So I'm going to draw it from here to here. That's going to be my triangle in the middle there, where the 3 lines overlap. And I think this is pretty accurate. See here. The further you go apart in slope, the better it gets. So if I really line this up well, I should be about here. That works. Great. Alright, so my last line there. Ooh, I don't really have a good equation of that line, so maybe I wouldn't pick that as one of the 8 with equations. So I'm not going to worry about that, okay? Alright, so my next steps would be to do my triangle calculations. The requirement is to have 4 triangles. Now you can create the art however you want. If you want it to be a figure, or if you want to just be abstract, that's fine. So let's say I finished my art. Let me go ahead and shade in. I'll choose a, let's see here, a different pen maybe. And let's see here, do I have any other brushes or tools? Yeah, here, I'll do like a marker here that's green, and I fill this in so it looks all nice, blah blah blah, and I'll do a light green here. You get the picture. I've done a nice stained glass. I would probably take more time than that. Now, my next step is going to be to write down these coordinates, because that's going to be really helpful in the upcoming time. So let's go ahead and label this, and I would label this on the actual grid as, I'll call it A, B, and C, and that's where I'm going to move into my next step, all my calculations. So The requirement for this is to have 4 triangles, one that is a right triangle, one that is a scalene triangle, one that is isosceles, and one that's equilateral. For each of those, you have to calculate the area, calculate the perimeter, and prove what kind of triangle it is. By proof, I mean explaining how your calculations show what it is. So in my case, I have triangle ABC. A was at, let's see here, 2, 4. B was at, I'm just going to list them here so I can use them in a second, 4, 3. And C was at 1, 2. And that's the triangle I'm on. So now I'd move over to my work page, and I would actually do my analysis on that triangle. Now you have 2 key formulas you're going to use, area, 1/2 base times height, and distance formula. However, I've got a little bit of a simpler way. So on my work area, I might use graph paper for this as well, and I might just do a little grid with this main triangle, ABC, just because this actually is easier for me. So there's A, B is at 4, 3, B, and C is at 1, 2. There we are. There's my triangle. So, how am I going to get the area? Well, to do area of this triangle, what I would do is I'm going to create an outer box, so to speak, or a rectangle, touching just the apex of each of these points on the outside. And I'm going to get the area of the outer box. So the area is going to be base times height of my outer box. In this case, my base is 1, 2, 3 squares, and 1, 2 squares up. So my area equals 3 times 2, which is 6 square units. Most grid paper you'll use will be centimeters if you want to write centimeters squared. Now to get the area of the actual triangle, what I'm going to do is start subtracting using the Pythagorean theorem. So I'm going to go ahead and find the area of this triangle. Sorry, not Pythagorean theorem. I'm going to find the area of this. So when it's a nice triangle that's on horizontal and vertical, remember, our height is always perpendicular to our base, and so our formula would just be 1/2 times base times height for the area of a triangle. So in this case, let me go ahead and number this outside triangle. I'll call this one number 1. So triangle number 1 would be equal to 1/2 3 times 1 times 3 times 1. Sorry, a little sloppy there. 1/2 times 3 is 1.5 square units. Alright, so I'm going to repeat that. Here's triangle 2, and this one is over 2 and down 1. Okay. So I'm going to do triangle 2. Triangle 2 was this one, 2 and 1, and that's still the perpendicular, so 1/2 times 2 times 1 is just 1 square unit. And triangle 3 is down 2 over 1. So this is actually the same. That's going to end up being equal to the other one. So let's see here. I've got triangle 3. There's 3. And that looks something like this, where it's 2 and 1. And again, I'll do 1/2 base times height. Area equals 1/2 times 2 times 1, which is 1 square unit. So how do I get the area of the actual triangle that I graphed on the stained glass? Well, I'm going to subtract each of these red triangles, number 1, 2, and 3, and the difference between that and the whole rectangle will be the area. So the whole rectangle was 6 square units, so I'm going to do 6 minus 1.5 minus 1 minus 1. What I get is 2.5 square units is the area of my triangle. And I'm going to label it A, B, C because those were the letters I used on the graph. And so you should move on to different letters for each one. Second, what kind of triangle is it? Well, I planned this in advance for this to be a right triangle. Technically, it's right isosceles, but I'm not there yet. So the reason I planned this in advance, and you may want to do your right triangle using horizontal and vertical lines because those would easily set you up. Remember, two triangles can be horizontal and vertical, and then the others have to be askew like this. They have to be sort of off. So I would recommend for your project do two of the triangles right on horizontal and vertical, especially the right triangle. So on this one, remember how I wrote the equations of the lines here in purple and red up above? Well, I would go back to those equations and say the line, and let's be specific about this. So the purple line is from A to B. So I'm going to go ahead and write in purple that this was a right triangle. And the reason I know that is because, and I keep my explanation can be fairly simple, is because because AB line, that line segment, or the line that extends from there, AB's slope is negative 1/2. And AC's slope was positive 2/1, which is the negative reciprocal. I'll abbreviate that for this video, reciprocal. So that would qualify as saying, what have I done so far? I've covered for my one triangle, I did the right triangle. I have calculated the area, and I've proved what kind of triangle, which one it was. I proved that that was a right triangle. My last step is calculating perimeter. Again, it'll help for me to regraph this. So let me take a second. We have A was at 2, 4. B was at 4, 3. B. And C was at 1, 2. C. All right. So to do perimeter, what I'm going to use is either use the distance formula for each of the sides. So I would do like side AB. In just a minute, I'll be done with my video. So for side AB, I would do square root of, and I would do y2 minus y1 squared. I would show my work, plus x2 minus x1 squared. I'd plug that into a calculator, get the square root, and get a rounded answer, maybe to the 10th place. Then I would take the sum of those sides. I would repeat by doing BC and AC. And that, by taking the sum of those sides, sum of the distance will give me the perimeter. Now the other way to do it is to again rely on the outer rectangle. So let me go ahead and draw that in again. So here's my outer rectangle method. And what I'm going to do is use a squared plus b squared for these right triangles to get the distance. So here, this right triangle is 2, 1. So I would focus on, here's AC. AC has leg is 1, the second leg equals 2. So I'm going to do 1 squared plus 2 squared equals c squared. So 1 squared is 1, 2 squared is 4, that would give me 5, which is c squared. So AC equals the square root of 5. I'm going to go ahead and repeat that process for each of those. So here I've got now AC, which I'm filling in black, is the square root of 5. To get the rest of the perimeter, I'm now going to do the next one. The next one is a right triangle of 2 and 1 here, 2 and 1, for this green side. So AB has one leg that is 1, and a leg that's 2, and it's a right triangle on this outside, so I can just do a squared, 1 squared, plus 2 squared equals c squared. And so that gives me 1 plus 4 equals c squared, or 5 equals c squared. And I get that c is the square root of 5. So that is the length for AB, side AB. Okay, so now I've got 2 of the sides. Let me do one last one, and I'll do it in red here. The length here from B to C is going to be equal to, again, I'm going to make the outer rectangle part the legs, 3 and 1. So that would be leg 1 is 3, and leg 2 is 1. So I'd do 3 squared plus 1 squared equals c squared, which is 9 plus 1 equals c squared. That equals 10. So the square root of 10 is side BC. Okay, so now all I need to do is the sum. I'm going to do the perimeter. I'll do this in my final color for today, light blue. The perimeter is going to be equal to AB plus AC plus BC. In this case, that's the square root of 5 plus the square root of 5 plus the square root of 10. I'm going to go ahead and use a calculator for this last step. So 5 square rooted plus 5 square rooted plus 10 square rooted equals 7.63 and a bunch of gobbledygook. So my perimeter, rounded to the 10th, is 7.6. units. Now, again, for your graph paper and the sake of yours, you may not want to number by ones here. You may actually want to skip space so that your units are larger, and even like do every 2 lines is 1 unit, and then 2 lines to 2 units. Also, you can skip numbering. If you don't want to number every single space, you can count to, their 4th square before you number it. Last, let's make sure I've covered everything. So now what we've done, we did our right triangle, we did our area, perimeter, and we proved what kind of triangle it is. So this triangle is done. You'd carry on doing your next triangle. Let's say you've got one over here, and it is GRE, and you're going to go ahead and do great work showing that it is either scalene, isosceles, or equilateral. Alright, I thank your minds and your hearts. That's how you would complete the entire extra credit. Have a good afternoon.